basically. And I have to apologize that I'm in between you and the nice weather outside, and it's going to be there for another 20, 30 minutes, and then you guys can go outside. Hi, I'm Maurits Kaptein. I'm a professor here at JATS of Data Science and Health. So I work here in Den Bosch, in this extremely nice building that you guys got to see today, at least. And I spent part of my time in Tilburg. And Peter and Karima asked me to briefly talk a bit about the type of research work we do here at JATS and some of the work that I contribute to in the lab that I had, basically. It has some links to some of the things you've been talking about today. It also has a few side steps, I would say. But then again, it's only going to be for 10 minutes. So if you're bored, you know, it's going to be gone quickly. Thank you for the attention. So I work in what we call the Computational Personalization Lab. Basically, what we work on in this lab, that's me and a number of PhD students and postdocs, is on different methods for personalizing treatments, in the very broad sense of the word. So personalizing is something we find in all kinds of places. In communication, for example, we try to find the right message for the right person. In education, we try to find the right educational program for the right student. In medicine, obviously, we try to find the right treatment for the right person. And maybe at some point, we'll actually try to find the right space or the right environment for the right people if we continue on the work that we've been talking about today. So within the lab, we treat this problem of personalization as a relatively abstract decision problem. The way we think about personalization abstractly is the following. Sequentially, over time, we interact with people. So some person might visit a website, or they might walk into a doctor's office, or they might walk into a classroom. And at each point in time, it's up to us to make a decision on what treatment to show to people. And those treatments, again, might be which product we show, which medical treatment we choose. And as we go along, what we aim to do is to maximize the outcome over all those sequential treatments that we do. So we treat personalization as a sequential decision-making problem. And this is also called in the literature a contextual multi-armed bandit problem. And I think this problem is interesting for a number of reasons. One reason why it's very interesting is, to me, it provides one of the most accessible formalizations of what we call the exploration-exploitation dilemma. So this is a very simple dilemma that we face when we make decisions in uncertainty based on data that we have. And it's the following kind of dilemma. If some new patient comes in to me as a doctor, and I have a choice between different treatments, basically I'm presented with the following choice. One is, I obviously want to assign the treatment that works best for this person, that I believe works best. So I want to treat this person and cure them. On the other hand, I might also have different types of treatments available, of which I'm less certain what their effects will be. In kind of the extreme case, this would be a newly developed drug, for example. If we newly develop a drug, we think it's promising, but we don't necessarily know in advance what their effects would be. So now, as a decision maker, I'm faced with this problem of deciding on one hand to administer this treatment that I believe is good, but that won't teach me anything about the other one, or trying out this new thing, which potentially isn't good, but at least it teaches me something. So at least it allows me to explore what the effects of my actions are for the person that I'm now interacting with. So this dilemma of balancing exploration and exploitation is something that is really ingrained in this problem. And just for the record here, the kind of traditional way in which we do this in medicine through the randomized controlled trial, so if we introduce new medication, really is just one possible solution to this problem. It's the solution where you start exploring the two different treatments during the trial, and after the trial you stop, you make a guideline and you exploit. This is only one way in which you could divide up exploration and exploitation in this kind of sequential learning. So what we look at in the lab is all kinds of different ways of thinking about this problem and dividing this up. So this is one reason why I think this problem is an important and interesting problem. A second reason that I find extremely important, that we do a lot of work on, is the simple example that in many of these decision problems, we actually have a lot of prior data available. So often, we have a lot of data on the effectiveness or possible effectiveness of different trials. Just to give you one concrete example, we do work together with the National Cancer Registry in the Netherlands. They keep track of over 2 million cancer treatments in the Netherlands and their effectiveness. And really what they want to use this data for is to, at the individual level, be able to say, if they find a tumor in you, what kind of treatment would be best for you? And you would imagine that having access to all of this data would actually improve your decision-making in this specific problem. But what is very tricky in this existing data is that all of this data is what's called observational data. So this is data of how people were treated according to different guidelines that are out there, meaning that actually that data doesn't really provide a very good way of estimating what would have happened for this person if we had done something else. Called causal effects of these different treatments. So that's a second problem that we often encounter when thinking about this personalization. On one hand is exploring or trading off exploration and exploitation. On the other hand, it's trying to learn and integrate existing data. However, often this existing data, that's observational data and not actual causal data. And then how can we include it to make better decisions? So this is the kind of abstractly the type of work that we do. And I just want to take a few minutes to highlight a few projects that we work on, and then I'm going to close off and leave the floor to the next speaker. There's a few concrete projects that we work on. Obviously, I just talked about this IKNL or the Cancer Registry project. Another project where we're trying to combine data to make better decisions in the healthcare domain. It's in a project that we do with the Twee Steden Ziekenhuis, it's the hospital here in Tilburg, where they're working on a randomized controlled trial that's comparing different ways of brain radiation to fight brain metastasis, so these are tumors in the brains. And really, there's two different types of treatment right now. One is the common treatment, and it's called whole brain radiation, and I think it speaks for itself. You radiate the whole brain. They also have a kind of an experimental version of treatment, which is called gamma knife, but it's just a very precise form of brain radiation. So you precisely target the individual tumors. Now, what they have there is that they need to decide which of those two treatments is actually beneficial for people, which might be different for different people. And they have the additional problem, which actually makes it a small data problem as opposed to a big data problem, that it's really hard to recruit enough people for this study. Because luckily, this is relatively rare, and it's a very special group of patients, so it's hard to get enough patients into this study. On the other hand, if you think about this study, similar studies have been done in the US. They have been done in other places in Europe. They have been done on slightly different target groups of people. So what we're trying to do there is combine both of our interests, and on one hand, try to see what is the best treatment for the next patient that come in, but also how can we include all of this data that was generated by all of these other studies to make better decisions in the current study that we're working on. So that's one of the places that we work on. Another place that we work on is the simple application of these methods for personalization in large-scale e-health applications. So these go, on one hand, from telemonitoring applications for people that have COPD or heart failure. We're trying to evaluate whether these kind of telemonitoring interventions will work, for whom will they work, when do we administer to them, these kind of questions. But also we're tracking people through Fitbits and kind of the wearable devices, and seeing how they respond to different existing e-health applications that are in the market, and seeing if we can personalize their offering based on how effective these e-health applications are. We, however, do not just work in the health domain. I also have a PhD student who works with a similar kind of frame of mind and a similar sequential decision-based approach, who works on personalizing churn offers for people. Churn is the simple idea that you cancel your subscription with some company. And what he works on is a kind of reinforcement learning or sequential learning approach to finding churn, where at each possible time point, we decide for each individual customer, given a bunch of their background characteristics, which offer we would send to which person. Here again, balancing. On one hand, we want to learn how effective offers are, so we want to explore. And on the other hand, we want to make sure we send effective offers. So we actually exploit. So it's a very common theme here. These are just a few of the types of projects that we work on here in one of the few research labs at JETS. And I would like to end up with just a note or a thought that I have while attending some of the sessions here and hearing some of the great work that was presented here, is that one of the things that we find out in a lot of this personalization work is that what is more and more important, or at least right now we start to understand the importance of this, is the actual surrounding of people, the context of people, the context outside of just who they are and kind of the feature vector, that's the way we're thinking about them, that describes these people, but possibly also the feature vector that describes the context or the space that they're in. So maybe some of the methods and tools that you've been talking about today could eventually actually help to personalize not just for a person, but also for a point in time and a point in space. And I hope that in that way we can use some of that data, maybe even some of the spatial data, to make better decisions for individuals. Thank you for your attention.
It's nice that we have the possibility to look a little bit in the kitchen of JETS and to understand what's going to happen with Peter when he has to cooperate with you and doing all that kind of wonderful things. Thank you very much.
Thank you.